Preparing for a HashiCorp Terraform Engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is Terraform, and why would an engineering team use it? Terraform is a declarative infrastructure as code tool that lets teams define desired infrastructure in version-controlled configuration. I would use it to provision consistent environments across cloud providers, review changes through pull requests, and automate delivery with plans and applies. Terraform builds a dependency graph and changes only resources that need adjustment. That improves repeatability and auditability while reducing manual errors. I would still distinguish Terraform from configuration management. Terraform primarily creates and manages infrastructure rather than configuring every operating system package. While answering, focus on infrastructure as code, declarative configuration, provider-based resource management, repeatability, reviewability, collaboration, and how Terraform differs from imperative scripting or configuration management tools. Question 2. How does Terraform determine which resources to create, update, or destroy? Terraform compares three inputs: the configuration, the stored state, and the real infrastructure observed through provider refresh. It calculates a dependency graph, then produces a plan showing additions, updates, and deletions required to reach the desired state. Some changes are in place, while immutable attributes force replacement. I treat the plan as a safety checkpoint, especially when it contains destroys or replacements. After approval, Terraform executes actions in dependency order and updates state to reflect the result. Make sure to cover configuration, current state, provider refresh, desired versus real comparison, dependency graphs, lifecycle behavior, replacement triggers, and why reviewing the execution plan matters before applying changes. Question 3. What is Terraform state, and why is it important? Terraform state is Terraform's record of the resources it manages, including provider identifiers, selected attributes, and dependency relationships. It allows Terraform to map configuration blocks to real objects and calculate incremental changes instead of rebuilding everything. In a team, I store state remotely with locking, encryption, access controls, and versioning. I avoid manual edits because state is operational data. If correction is necessary, I use commands such as statemv, stateerm, or import carefully and document the change. In your answer, talk about state as Terraform's resource to configuration mapping, stored attributes, dependency metadata, drift detection, sensitive data exposure, team coordination, and the risks of manually editing state files. Question 4. How would you design a secure remote backend for a production Terraform environment? I would use a supported remote backend, such as an encrypted object store with a locking mechanism, and separate state by account, environment, or workspace boundary. Access would follow least privilege through short-lived identities, with encryption in transit and at rest, versioning, audit logging, and restricted network access. I would enable state recovery and test it. Because state can contain secrets, I would minimize sensitive values, mark outputs sensitive, and ensure backend credentials never appear in configuration or logs. Be sure to mention remote storage, state locking, encryption at rest and in transit, least privilege access, versioning, audit logs, isolation by environment, recovery procedures, and protection of sensitive outputs. Question 5. What is the difference between Terraform resources, data sources, and providers? A provider is a plugin that translates Terraform operations into an external system's API calls. A resource represents an object Terraform creates or manages, such as a network or database. A data source reads existing information without managing its lifecycle, such as an approved subnet or current account identity. For example, I might read a shared VPC with a data source, then create application subnets as resources. Provider version constraints keep behavior reproducible and make upgrades deliberate. Focus on providers as plugins, resources as managed objects, data sources as read-only lookups, configuration dependencies, version constraints, and a practical example showing how these components work together. Question 6. How do Terraform modules improve infrastructure design? Modules package related resources behind a reusable interface of variables and outputs. I use them to standardize patterns such as a production network, while keeping environment-specific decisions at the calling layer. A good module has clear ownership, validation, minimal assumptions, documented outputs, and semantic versioning. I avoid creating a giant abstraction that hides provider behavior. For example, a network module can expose subnet identifiers and logging options, allowing application stacks to compose infrastructure without duplicating implementation details. In your answer, cover encapsulation, reusable interfaces, inputs and outputs, sensible defaults, composition, versioning, ownership, documentation, validation, and avoiding overly generic modules that hide important infrastructure behavior. Question 7. When would you use count versus for each? I use count when instances are essentially interchangeable and a simple numeric quantity is sufficient. I use for each when each instance has a meaningful stable key, such as a map of named buckets or environments. With count, removing an item can shift indexes and cause unnecessary replacements. With for each, Terraform tracks instances by keys, making changes safer. I also avoid changing collection identity casually, because converting between count and for each can require state migration rather than a normal apply. Make sure to explain indexing behavior, stable keys, collection types, refactoring risks, identity preservation, and why for each is usually preferable when individual instances have meaningful names or independent configuration. Question 8. Explain Terraform's dependency graph and implicit versus explicit dependencies. Terraform creates a graph from resource references. If a subnet references a VPC identifier, Terraform automatically knows the VPC must exist first. That is an implicit dependency. Terraform can then parallelize unrelated work, improving speed. I use depends on only when a real dependency is invisible in arguments, such as a required policy attachment or external initialization step. Overusing it reduces parallelism and can create broad replacement behavior. My preference is to model data flow explicitly through resource attributes whenever possible. While answering, discuss references creating implicit edges, graph-based parallelism, module relationships, depends on as an exception, hidden dependencies, and the importance of expressing actual data flow instead of forcing sequencing unnecessarily. Question 9. How would you investigate unexpected changes in a Terraform plan? I first classify the change, in-place update, replacement, or unexpected destruction. Then I inspect the exact attribute, configuration history, provider version, state entry, and refreshed remote value. I check whether defaults, computed fields, unknown values, lifecycle rules, or external drift explain the diff. I would reproduce with a clean plan, use state inspection and provider documentation, and avoid blindly applying. If the change is legitimate, I document it. If not, I correct the root cause before rerunning. Be sure to mention reviewing the diff, refresh behavior, state and configuration comparison, provider versions, computed values, lifecycle settings, recent external changes, targeted diagnostics, and validating the explanation before applying. Question 10. What is drift, and how should a team respond to it? Drift occurs when real infrastructure differs from Terraform's declared configuration, usually because someone changed it outside Terraform. A plan can reveal that difference after refreshing provider data. I first determine whether the change was intentional, emergency-related, or unauthorized. Then I either update configuration to preserve the desired change, apply Terraform to restore the declaration, or import and model an existing object. Finally, I address the cause through permissions, operational policy, drift detection, and documented break glass procedures. Focus on out-of-band changes, refresh and plan behavior, distinguishing intentional emergency changes from unauthorized modifications, reconciliation options, ownership boundaries, monitoring, and preventing recurring manual changes. Question 11. How do you manage secrets safely in Terraform? I avoid hard-coding secrets in Terraform files, variables committed to Git, or command history. I prefer retrieving values from a managed secret system or using short-lived credentials through workload identity. Marking a value sensitive suppresses display, but it does not necessarily remove the value from state, so the backend still requires strong encryption and access controls. I also prevent secret leakage through plans, logs, crash files, and outputs, and design rotation so applications can update without embedding credentials permanently. In your answer, cover avoiding hard-coded secrets, secret manager integration, sensitive variables and outputs, state exposure, logging risks, ephemeral credentials, rotation, backend security, and the limits of the sensitive flag. Question 12. What are Terraform lifecycle meta-arguments, and when would you use them? Lifecycle meta-arguments modify how Terraform handles resource changes. I use create before destroy when a replacement can safely coexist and downtime matters. Prevent destroy is a guardrail for critical data stores, though it can block legitimate changes. Ignore changes as appropriate for attributes intentionally managed by another system, but dangerous if used to hide drift. I keep these rules narrowly scoped, explain their operational implications, and remove temporary protections when their purpose ends rather than accumulating permanent exceptions. Make sure to discuss create before destroy, prevent destroy, ignore changes, replacement behavior, operational trade-offs, temporary safeguards, and why lifecycle settings should be narrowly scoped and reviewed carefully. Question 13. How would you import an existing resource into Terraform? I begin by writing a resource block that represents the existing object and selecting the correct provider configuration. Then I import the provider-specific identifier into the exact Terraform address, using a map key or module path when necessary. Afterward, I inspect state and run a plan. The goal is a no-change or intentionally small plan. I reconcile omitted arguments, defaults, and immutable attributes before applying anything, because an incomplete configuration can immediately propose replacing the imported resource. Be sure to mention writing matching configuration first, identifying the correct resource address and provider ID, running import, inspecting state, generating or reconciling arguments, planning, and avoiding accidental replacement after import. Question 14. How do Terraform workspaces differ from separate state configurations? Workspaces provide multiple state instances for one configuration, which can be convenient for lightweight environment variations. However, they are not a complete security boundary because configuration, credentials, and permissions may remain shared. For production isolation, I often prefer separate root configurations or backend keys, cloud accounts, and access policies. Workspaces can fit preview environments or consistent stacks, while independent configurations better support different ownership, compliance requirements, provider settings, and blast radius controls across development and production. While answering, compare workspaces with separate backend keys, directories, accounts, or repositories. Discuss isolation, access control, blast radius, promotion workflows, and when workspaces are or are not appropriate. Question 15. How would you structure Terraform in a CI/CD pipeline? My pipeline runs formatting, initialization, validation, linting, security checks, and a plan on every change. The plan is stored as an artifact, reviewed in the pull request, and checked against policy before approval. Applies run only from a trusted branch or Terraform cloud workflow, using short-lived credentials and remote state locking. I serialize production applies, restrict who can approve them, and capture logs. Afterward, I verify outputs and service health rather than treating a successful Terraform exit code as full validation. Focus on formatting, validation, linting, security scanning, initialization, plan artifacts, pull request review, policy checks, approval gates, remote execution, serialized applies, credentials, and post-apply verification. Question 16. How do you test Terraform modules and configurations? I use layers of testing. Formatting, validation, linting, and static security analysis provide fast feedback. Module tests can assert planned resource properties and outputs, while integration tests apply representative infrastructure in an isolated account and destroy it afterward. I also test policy rules and module contracts, including required inputs and expected outputs. For mature modules, I run tests across supported provider versions and representative combinations. The key is catching interface and behavioral regressions without making every pull request unnecessarily slow. In your answer, discuss formatting and validation, static analysis, unit-like plan tests, integration tests, ephemeral environments, policy testing, contract checks, cleanup, provider mocking where possible, and balancing speed with realism. Question 17. What is provider version pinning, and how would you upgrade a provider safely? I pin providers with an intentional version constraint and commit the dependency lock file so teams and C resolve the same checksum package. For an upgrade, I review release notes and breaking changes, update the constraint deliberately, regenerate the lock file, and run validation and plans in an isolated environment. I test representative modules, examine unexpected diffs, and roll out gradually. Provider upgrades can change schemas or defaults, so I treat them like application dependencies, not a routine blind refresh. Make sure to cover required providers constraints, lock files, upgrade intent, changelog review, isolated plans, compatibility testing, state migrations, staged rollout, and rollback considerations for provider-related changes. Question 18. Why should provisioners generally be a last resort? Provisioners execute scripts during resource creation or destruction, but Terraform cannot model their internal actions reliably. They may fail because of networking, credentials, timing, or non-idempotent commands, leaving infrastructure partially configured. They also make drift harder to detect and can complicate replacement. I prefer provider resources, immutable images, cloud init, or a dedicated configuration management system. If a provisioner is unavoidable, I isolate it, make it repeatable, define explicit dependencies, and document failure recovery and rerun behavior. Be sure to explain provisioner fragility, non-idempotence, dependency and connectivity problems, weak drift modeling, destroy time risks, and preferred alternatives such as cloud init, images, configuration management, or provider resources. Question 19. A Terraform apply failed halfway through production changes. What would you do? I would first preserve the error details and avoid making unrelated manual changes. I would inspect the apply logs, state version, provider responses, and actual infrastructure to determine which actions completed and which failed. After fixing the underlying issue, I would refresh or generate a new plan and verify that Terraform recognizes completed resources correctly. I would review replacements and destructive actions with stakeholders before continuing. If service risk is high, I would use the documented rollback or recovery procedure rather than improvising. Focus on stopping parallel manual intervention, reviewing logs and state, identifying completed and partial actions, checking real infrastructure, resolving the underlying error, refreshing safely, and rerunning a reviewed plan with rollback awareness. Question 20. How would you explain a Terraform design decision to a non-infrastructure stakeholder? I would connect the design to outcomes rather than lead with Terraform terminology. For example, remote state locking prevents two releases from changing the same environment simultaneously, reducing outage risk. Separate production state limits the blast radius, while automated plans improve review speed and auditability. I would explain the trade-off, such as added setup or approval time, quantify it where possible, and show how the design supports availability, security, compliance, and predictable delivery. That makes infrastructure decisions understandable and actionable. In your answer, emphasize business impact, risk and reliability, cost, delivery speed, clear trade-offs, measurable outcomes, concise diagrams, and translating technical choices into availability, security, compliance, and operational consequences. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.